Okay, good afternoon, students. Now, after the variable data and attribute data, once when you collect the variable and attribute data, that data needs to be placed and analysis is required from that data. For that purpose, we plot different charts apart from the bar chart, histogram chart and polygon chart. Apart from these charts are just showing the trend. But now the variable charts or the attribute charts will show you the exact position of your process, whether your process is in control or not. They will show the exact position. So now in front of you, you can observe that two types of data when we have collected. That data is variable data and attribute data. So this is charts for variable data. Now here you can find X chart and R chart. These are the range chart and average chart. These are the two charts generally used for the variable data. Sometimes a sigma chart, that is process capability chart, it is also termed as the S chart also. Sometimes sigma charts also used for the variable charts. Now for attribute data, we know the difference between a variable data and attribute data. Variable data is in the form of millimeter, inches, and it is the exact value. Whereas the attribute charts are just acceptance or rejection, defects, defective, all these things, accepted or rejected. So for charts for attributes, that is charts for defective atoms and charts for defects per unit. Because if the unit is bigger, then we need to find out the how many defects are there in a unit. For that purpose also the charts are different. Here chart for defective atoms are fraction defective, that is varied sample size. When the sample size is variable, then P chart is used. For constant sample size, for defective, NP chart is used. Now for charts for defects per unit, C chart, constant sample size, C chart is used. For variable sample size, U chart is used. Now we will discuss all these charts in detail, how to calculate the limits of the chart, how to calculate the mean of the chart, how to plot the chart, and all those things we will discuss one by one. Now this is the general control chart selection, how to select. Quality characteristics, if it is variable and attribute. Again, variable and attribute, if data is available. If in the variable data, if n number of samples are greater than or equal to 10, then you need to go for the x bar and r chart. If it is less than, then you need to go for the x bar and r chart. If it is greater than, you need to go for the x bar and sigma. Because whenever the number of samples increases, then the computation also increases. So a smaller values will give a better results, but the number of samples, as the number of sample increases, calculation also increases. So if you go for the attribute defective and defects, so if it is constant sample size, then go for P or NP chart. If it is not a constant sample size, then variable, then it is P chart. Sometimes for both the sample size, some in the organization plot the P charts also. If a bigger sample is there, so many defects are there, then constant sample size you need, then go for, if constant sample size is there, then go for C chart. If the sample size constantly varies, then go for U chart. This is the general perception of the chart, how to select the charts. Now, before going for a chart, how we have collected the data in the form of attribute and variable data. Now, here some concepts how to collect and on which basis the subgroup is formed. Now, what is the basics of this subgroup? What is subgroup? Subgroup is a group of samples. It is a group of samples. Sample size, what we called it as a sample size. The basic purpose of drawing chart is to analyze the shift in the process. Shift means whether the product is at the mean dimensions or whether it is shifting towards the upper control limit or lower control limit. That is the shift. That term is called a shift. Therefore, all samples should be drawn from the same population. Same population means all samples should be drawn from the same machinery or the same process or same. So if you take the different samples from the different populations, there are the chances of the readings or the chances of the what we can say the trend may change. So one subgroup should contain atom from one population. One subgroup should contain subgroup. What is subgroup then? Subgroup is a size of sample. Suppose there are I have taken 5 samples of 4 atoms in each, means one subgroup is having 4 atoms. Then 2 samples from different population are explained. Samples should not be taken exactly at the equal interval of time. Sample should not be taken exactly because at that time, if you take exactly at that time, suppose you are taking a sample at 10 a.m. daily, then might be because of the environment change, because of the process change, because of the so many factors are there, you may find the same results. So sample should be taken either 950, 1025 like that. You must change your interval. Samples, subgroup size of 4 or 5 is mostly accepted subgroup size. It is easy to compute. I have already told you that sample size should be small. Otherwise, the calculation procedure goes on increasing. But sometimes large sample groups is the necessity of the demand. That large subgroup size 10 to 20 is sometimes advantageous to make chart more sensitive to small variations. If the readings are more, then you can analyze more sensitive information from the charts. Now, once you have collected the data, you have tabulated the data. Now, for charts, we will discuss these charts, how to calculate the different range for this chart. Suppose type of chart, X bar and R chart. If it is less than 10, but usually 3 to 5. Just in the before this slide, we are seeing that generally we keep it 3 to 5. Central line is calculated as X double bar for the X bar. For the X bar chart, central line is calculated as X double bar. X double bar is nothing but the X1 plus X2 plus X3. Xk means Xn. We can say small n. Xn is the, suppose 5 samples I have taken. So 5 divided by subgroup size is suppose 5. Then subgroup size is n. So X1 plus X2 plus X3 by n. Now, how to calculate the control limit? Control limit, upper control limit. UCL is nothing but the upper control limit. Upper control limit is X double bar, where we have calculated X double bar plus A to R bar. And lower control limit is X double bar minus A to R bar. Now, here we know we can calculate R bar value from R chart. R chart is R1, range 2 plus range. How much is the range? Divided by n. This R bar can be put here. X double bar, we have just calculated this X double bar. Now the unknown factor is A2 and A1. A2 and A1 are the standard values for a particular subgroup. From where these standard values have been derived? These standard values have been derived from a longer period of experience in the industry. These values are generally given in the problem. Now, if you look this chart is also available appendix in your book. Now, here number of observations in a subgroup. Here number of observations we have 5. So, factor for X bar chart A2 value of A2 is 0.58. Now, factor for R bar is having a same, R bar is having values like this, D3 and D4 values. I will again go to back slide. Now in this slide